Hello again. We are back with another video about the Arterials AI traffic counting software. We have received some emails and inquiries about using the software to conduct turning movement counts at intersections. So we decided let's just make a demo video and show you how it's done. Now here I have a simple three-leg intersection with three approaches. I have a southbound approach, an eastbound approach, and a westbound approach. And we're just going to take this video into the software and see how we're going to process it over there. So I'm just going to open up the AI traffic counting software. And I'm just going to run the software in trial version. So I'm going to have a 20-minute limit on the video. If you need to run anything more than 20 minutes, like let's say 12 hours, then highly recommended you get the full version. You can get the full version by either clicking this link or going to arterial.co. So I'm just going to go to find that video of that three-leg intersection. There we have it. And we're just going to give it a name. This intersection is Jerry Road at Wisconsin Drive. And we saw from the video that we have a southbound approach, an eastbound approach, and a westbound approach. We don't have a northbound approach. And because it was just about a 5-minute clip, I think, I'm not going to bother with a 15-minute interval. 1-minute interval is okay for this demonstration. And we're just going to obtain both our fully annotated videos and our quality assurance 1.5-minute snippets. And we're going to share our results into our test folder. So now when I click start, I'm presented with the first frame of my video, and it's asking me to draw the southbound approach line. So I can see this is my southbound approach line, or my southbound approach. But I can also see that there is this huge left turn channel that is for the southbound left movement. So in the real world, we are going to see strange cases like this. So how would I draw my approach line? If I drew my southbound approach line simply like this, I'm not going to be covering that southbound left movement. So that's a problem. So what I really need to do is actually draw my southbound approach line such that it's extending all the way so that if a vehicle is going to cross it for that southbound left channel, I can capture it as well. So I'm going to hit escape to confirm. Now it's asking me for that southbound left movement line. So for every count we need an approach line, which we have, and the movement line. So if there's a vehicle passing southbound through this channel, it's going to cross this line, and then I expect to see it again somewhere over here or over here. I'm just going to draw this line over here for the southbound left movement. Now for the southbound through movement, because this is a T intersection, no cars are going to be going straight over here. I don't really need a southbound through movement. I can just draw a random line somewhere in the air over here, and it's not going to matter. I confirm that, and now for the southbound right movement. That's for all these vehicles that are going to cross this line and then make that right turn onto Derry Road. So they should be, I expect them to be crossing this line. I just drew this line over here. So if that white car or the black car passes the green line and makes a right turn, it's going to be crossing the red line around this point. I could also draw this line over here, but it might just be more efficient to do it over here. Same thing. Now it's asking for the southbound U-turn movement. So that's if a vehicle from the Wisconsin Drive is going to make a U-turn and go back this way. If it does so, I expect it to cross this line. And for the pedestrian line for the southbound approach. Now the pedestrian line is going to be indicated on the approach itself, not for the passengers who are moving southbound. There's no such thing. So the southbound approach has this crosswalk over here. So we're just going to draw this line where we expect to see pedestrians to be crossing over. Now I've confirmed the entire southbound approach. Now it's asking me to draw the approach line for the eastbound approach. So here's our eastbound approach, and again we see we have some kind of channelized turn that we want to capture over here. If I drew my eastbound approach line over here, I won't be capturing that channel. So I'm just going to draw it a little further back here so that a vehicle is going to cross, whether it's turning left or going straight, it is going to cross that green approach line. Here we go. Escape to confirm. Eastbound left movement, that is that movement over here. That's the eastbound left movement. Now I need to be a little careful. If a vehicle moves through, I want to make sure that this line is not too long that it actually intersects with the through movement as well. So I'm just going to draw a short little line, just enough that it avoids the through movement and captures that left turn movement. For the through movement, that white car over here or the white car over here, when it crosses its approach line, I expect to see it somewhere over here. I could capture it over here as well, or over here. It's really up to you. For this demo, I'm just going to draw that line over here. Escape to confirm. There is no eastbound right turn movement. Were they going to go off the screen? I don't think so. So I'm just going to draw a line somewhere in the air over here, which is irrelevant. No vehicle's ever going to cross that. And for the eastbound U-turn movement, if that white car on Derry Road suddenly decides to make a U-turn and go back, I should be capturing it somewhere over here. So I'm just going to draw my line right over here for that white car, or for any U-turning movement. And for the pedestrian line, now here's another interesting situation. We don't actually have a crosswalk along the east approach, the eastbound approach. We do have a crosswalk over here. I could draw a random pedestrian line somewhere and just forget about it, but I do want to capture some active transportation movement. So I'm just going to utilize the crosswalk that I do have. So I'm just going to draw a pedestrian line over here that is intersecting with my crosswalk on the eastbound approach. Now we're going to do this one more time for the westbound approach. So I'm going to first draw my westbound approach line. Again, I'm going to be careful not to draw my westbound approach line all the way over here like that. That's even because it's spilling over into the eastbound lanes. So if a vehicle was traveling eastbound, it would end up crossing my westbound line, and that would be wrong. It would start messing with my data. So I'm just going to draw a simple, clean westbound approach line that is not going to intersect with my eastbound lines, but it is going to capture all my westbound movements. Escape to confirm. Westbound left does not exist. Draw it in the air. Westbound through does exist. So if a vehicle goes straight, it's going to cross the green line, and it's going to cross this red line over here, or somewhere down the line over here. I'm just going to draw it over here. Westbound right, it's all these guys who are turning onto Wisconsin Road, like this black truck. I could draw the line this way. If I draw the line this way, I could make some errors getting through movements crossing my right turn lane. So I'll be a little careful. Maybe I'll draw it at an angle. That way there's no way for a through movement vehicle to actually cross this line, but a right turning vehicle would definitely cross this line. So I'll confirm that, and then for my westbound U-turn movement, when they turn back onto Derry Road going in the eastbound direction, I expect to see them crossing the red line somewhere at this point. And finally, my pedestrian line, I can see my westbound approach crosswalk. I'm just going to draw my westbound approach pedestrian line over here. And I think I've drawn all my lines, so when I hit escape to confirm, the AI traffic counting software is going to start processing it one frame at a time. And we're just going to wait for it to do its thing, and then I'll get back to you after it's done. Okay, so we're just about done processing here. As always, highly recommended to use a machine that has a GPU on it. If you're going to use a computer without a GPU and rely fully on CPU, then it will take a substantial amount of time to process a video. With the GPU, you will be saving yourself a lot of time. So now it's just finalizing, exporting everything to Excel, locking up the videos, and processing complete. So now we can view our results. So I'll just open up the fully annotated video for this discussion, and we can see how we drew all of our lines and how the vehicles are passing through them. So we see a car on the westbound approach and across that westbound right turn line. Now the southbound vehicles have started to move, so this one went through the southbound line, and southbound right has registered 1 vehicle, 2 vehicles, 3 vehicles, and so on. We can also see for that huge channelized left turn lane, the southbound left line is capturing those movements as well every time a vehicle passes through it. Now the eastbound approach has opened up, so now we're capturing eastbound through movements. And we're also capturing some westbound through movements because apparently this movement at the bottom of the screen is free flow. It's not signalized, so that's okay. And any moment now, we're going to see that westbound right turn open up and start moving. So here, this black car passed the approach line, and now it should cross the westbound right line. So here we're registering 1 count, 2, 3, 4, 5, and so on. So you get the point, right? I can just skip over to the end of this video and just see how all my lines are stable, how everything is holding up. Now I can go into my actual data and see how we have processed what the Excel count looks like. And here we can see how the software has compiled for us in Excel about 1, 2, 3, 4, 5, 6 different classes. So we have cars, trucks, buses, the totals, pedestrians, and persons. So for the totals, that's just every single vehicle class. We can see the vehicle movements. Our turning movements diagram is representative of a 3-leg intersection as we expected to see. And we can see how there were 35 westbound through movements, 24 westbound right movements, and so on. And we can also see Derry Road and Wisconsin Road, that 1-minute interval that we had set in our input field, and how all of our vehicles have been counted into these classified turning movement counts. Southbound left, southbound right, eastbound left, eastbound through, westbound right, and then the pedestrian movements as well. So that's pretty much it. That's how the air traffic counting software is helpful for your turning movement counts. I do want to take a moment to talk about, however, 4-leg intersections, which are a little more complicated. Now, for 4-leg intersections, it does get a little difficult because of the size of some of these intersections. Like if I look at the Shinjuku intersection, for example, this is an absolutely massive intersection with multiple travel lanes in either direction. Now, the problem here that people might sometimes face is the approaches that are further away from our field of view. So in this case, it would be this approach over here, let's assume it's southbound, and the westbound approach. These things are a little far away, and it makes it difficult for us to draw our lines, and it also makes the AI to kind of hold on to the detection and detect reliably. So it is kind of recommended in a practical setting that if you're dealing with a situation like this, use multiple cameras. Use a camera for the intersection, for the 2 approaches at a time. Use one camera for, say, the northbound and eastbound approach at an angle, then use a second camera zoomed into the westbound and southbound approach so that you're not relying on a single video for all of your turning movements. However, there are some very good examples of high quality videos for 4-leg intersections. For example, this one, I would like to show this one. This one is kind of excellent. We can see all of our movements. The video resolution is very high. All the approaches are clear. The field of view is absolutely beautiful. The AI should have no problem at all counting this intersection. However, I know in real life this kind of situation is a little difficult to attain, but you got to do your best. Here's another good example of a very good video for a 4-leg intersection that is showing all the approaches and all the movements quite clearly. The resolution is also very nice. However, same thing over here, the far off approach, where we see all those motorcycles, that is a little far. So what kind of approach line are you going to draw? You might end up with a very small approach line. And the vehicles won't be counted or being detected by the AI until they've made their way a little bit into the intersection. So you might have to think about that when you're drawing your lines. So to address all of these nuances and concerns, we have created a resource. We have created a guideline for the video quality standards so that you know what kind of video you should be recording before you start running the software. So you can go over, I'll leave the link in the description, you can go over to arterials.co and find our video quality standards, recommended video quality standards, where we talk about resolutions, camera height, camera angle, and some examples of good and bad videos so that When you bring these videos back into the office from the field, you won't be struggling to detect counts. So do have a go through of this. I will leave the link in the description. If you have any other questions, please feel free to reach out. You can email us at info@arterials.co or support@arterials.co, this contact form on our website, or you could leave a comment on this YouTube video and we will get back to you.